Welcome to our review for Exam 1. Let's go ahead and get started. So first off, we are just trying to label inferential or descriptive statistics. So we're looking for keywords here. First, the average number of cans of pop consumed in the U.S. is calculated. So keyword there is calculated. Doesn't say that we're doing anything with the calculation, drawing a conclusion or anything like that. So this was going to be descriptive. And a market study is performed to determine, okay, we're going to try to determine something. We're going to try and draw a conclusion to determine which soft drink Americans prefer. That's inferential. And remember the general idea behind inferential statistics is that you draw information from the sample and you generalize to the population. That's the central idea that's going to come in the next problem. So here we have a poll of 950 registered voters. We're trying to determine support for the governor's school funding reform plan. What is the population? Well, we polled the 950, so that's not the population. So the population would be, this could be either all Illinois voters, or it could be all Illinois residents. Let's say all Illinois residents. Seems like even if you're not registered to vote, you would still care about the funding program. The sample is going to be the 950 registered voters. So not just 950. 950 what? 950 candy bars? No. 950 registered voters from Illinois. So that's our sample. What's the characteristic under study? We're trying to determine support for the school funding reform. So school funding support. Or the school funding reform support. And then what are some possible inferences that could be made? So an inference here, you're going to generalize. You want to go from the sample, gather information about the sample, generalize to the population. That's the key idea of inferential statistics. So one possible inference or possible conclusion we could make on the results of this poll is that, say, for example, if a majority of the sample supported the reform, so I'll say a majority of the sample supports the reform, then we might conclude that a majority of the population will also. So, or a majority of all Illinois residents. So really key to identify the sample and the population when you're trying to look at some conclusions. And then, if a majority of the sample did not support the reform, then we might conclude that a majority of the population, all Illinois residents, would also not support it. So more than one possible conclusion there. Next up, we are making a stem and leaf plot with some decimal data here. 4.9, 3.89, 3.92, 4.35, 4.85, 4.48, and so on. Looks like the lowest value here, I see a 3.87 there. And let's see, anything lower than that? No, I think 3.87 is probably our low. And then on the high side, I see 4.9 that we started out with. Yeah, so it looks like 4.9 is the high side. So we probably want to do two-digit stems, the ones digit and the tenths digit for our stems, and then the hundreds digit for our leaf. So we're not told, what this information represents, but we want to do the plot in a way that gives the most information about the data. We certainly don't want to group it just in the 3s and the 4s and have two-digit leaves. That's not going to give us very much information. So let's put the larger numbers at the top. So we could have a 4.9 row, 4.8, 4.7, 4.6, 4.5, 4.4, 4.3, 4.2, 4.1, 4.0, 3.9, and 3.8. So those are our stems, and then leaves are just going to be the hundreds digit. So in the 4.9s, I see that 4.90, and I don't see any more 4.9s, so I'll put a 0 in that row. 4.8s, see a 4.89 there, and then let's see, 4.85 past one, so 4.89, 4.85. So we're going to have a 5 here and then a 9. Remember, they increase as they go this direction. They increase as they go to the right. And then 4.7s, don't see any. Don't see any 4.6s. See a 4.53 here. So we got a break there, 4.53. 4.4s. Got a 4.48 there and a 4.42 there. So 2 and an 8. Cross those guys off. 4.3s. See 4.35 right there. Don't see any 4.2s. 4.1s, we got a 4.11 and 4.19. So we'll have a 1 and a 9 as our leaves. So gap and then 1 and 9. Don't see any 4.0s. 3.9 here. 3.92. So 2 here. And 3.89 and 3.87. So we're going to have a 7 and a 9 to finish up. So you can do the plot and then reorder to be increasing, or we just notice what the numbers were and put them in the increasing order. So now we want to analyze the stem and leaf plot. So here I actually haven't asked you to do that. I just said do the plot in a way that gives the most information, but I could say interpret the plot. So if I say interpret the plot, then we want to do SAUCE. So center, outliers, symmetry, and spread. Is our acronym. So the center of the data here, well, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So we should have 6 above and 6 below the center. 1, 2, 3, 4, 5, 6. So your center would be in here. approximately between the 4.3 and the 4.4. So center, we could say approximately 4.35. Okay, and there's some room to estimate there. Outliers would be things that are away from the rest of the data. Now we do have some small gaps here, but we've got a big gap here where we jump from 4.53 up to 4.85. So I think these guys up here we could definitely consider to be outliers. So that's the 4.85, 4.89, and the 4.90. And then we have a small gap here, and we have a small gap here, but we've got those repeated gaps, and this goes from 4.19 to 4.35. That's not near as big a gap here. So we really haven't talked in detail about how far something has to be away from the middle to really be an outlier, but look, here's the center. Okay, these guys are really not that far from the center compared to these numbers. Okay, and then plus the gap is twice as big. So I probably wouldn't fault you, if you said that, these numbers were outliers and these numbers were outliers. But I think the clearest case of outliers would be these guys up here, because this is the biggest gap in the data. Got a big gap. And then symmetry of this, well, let's see, if we look at the curve that goes across the top of the data, it would look something like this. And, well, the center going down through here. Yeah, we've got two areas of concentration above the middle, and we've got two areas of concentration below the middle. We actually have a fair amount of symmetry there. I mean, it looks somewhat similar above and below the middle. Not exactly, but so you could say, for example, you could say that this was, that it was fairly symmetric. Certainly not a perfect bell curve, but we do have some symmetry going on there. This bump is kind of offset by this one, and then this bump is kind of offset by this one. Spread, this data, it's not all piled up in the middle around the center. Okay, it's fairly spread out here. So our spread in numbers, our range is 3.87 up to 4.90. But the data are fairly spread out. They're not concentrated. So as opposed to if we had all of the data, was just like, between 4.2 and 4.5 with just, one outlier or something. That would be fairly concentrated data. But this is pretty spread out. And then also remember in the homework we did back-to-back stem and leaf. So it's possible I could change this and ask you a back-to-back stem and leaf. Okay, number 4, we're constructing a frequency histogram. So remember, in order to do the histogram, you have to do the tables first. You have to do the frequency table or the frequency distribution. And I've got a note here, also know how to do a grouped or a relative frequency histogram. So this one is not going to be group data because we've only got number 0 is the lowest number up through 7 is the highest number. So we've only got 8 different numbers. So it really doesn't make sense to group it. So we'll go ahead and make our frequency table here. So we're going to list the number of cards, number of credit cards that they've got. Versus the frequency. So this could be 0 through 7. So 0, 1, 2, 3, 4, 5, 6, and 7. And then we look how many people have 0 cards. I see 1 0 here. Looks like that's it. So that's got a frequency of 1. How many people have 1 card? Let's see, 1, 2, 2 people have 1 card. How many have 2 cards? So I see 1, 2, 3. And how many have 3 cards? So 1, 2, 3, 4, and 5. And number of people that have 4 cards. So looking for 4s here. 1, 2, and 3. 3 4s. Number of people that have 5 cards. 1 and 2. No 6s in here. There's just a 7, 2 7s that are left. So there's a 0 frequency there, but we still keep that because that's showing a gap in the data. And then 2 7s. So this is our frequency distribution. Now, if there was more data, if it was much more spread out, then we might want to group it. Or if I ask you relative, then remember with relative frequency, you're doing one more column in the table here, which is going to be the percent column. So you would add up all these frequencies and then do 1 out of the total, 2 out of the total, 3 out of the total, etc. Alright, so now let's work on the histogram. The histogram is the bar graph, remember? So frequency is going to be on our vertical and the number of credit cards is just going to be on our horizontal. And we want to center the bar over each number because there's only one number in the grouping here. Our groupings are just one number at a time. So we have a 0 here for 0 cards, and then 1, 2, 3, 4, 5, 6, and 7. And then our frequencies, lowest frequency is 0, highest frequency is 5. So this is going to be frequency on the vertical. And 1, 2, 3, 4, 5 is the highest frequency. And so for 0 cards, we've got a frequency of 1. So we want to do a bar of height 1. So it's going to look like that. And then 1 card, we've got frequency 2, so we're doing a bar of height 2. Over the 1, centered over the 1, we're going up to height 2. So about like that. And then 2 cards, we've got frequency of 3. So we're doing a bar of height 3. So we're going up to height 3, right there. 3 cards, we've got a frequency of 5. So we want height 5. So this bar centered over 3 should go up to height 5. Okay, so height 5 right there. And then 4 cards, frequency of 3. So this bar centered over 4 is going to go up to height 3. There. And then 5 cards, frequency of 2. So we are doing bar of height 2 again. About like that. And then 6, there's no bar. Frequency 0. And then 7, we've got frequency of 2, so height 2 again. It's about right in there. Okay, so there's our distribution. And notice that we've got pretty close to a nice bell-shaped distribution. Got a little gap in here, and then 2 7s that are out there. But if we didn't have that, this would be almost a perfect bell-shaped distribution. So you'll want to look back over the homework and review relative frequency, and then look at a grouped problem. Okay, in the next questions, we're using this graph on gasoline prices. So this is just interpreting a graph. So they ask us here, during how many months was the price of gasoline greater than $1.10? Well, every month this year, huh? Okay, so greater than $1.10. So $1.10, this is a dollar on the vertical, $1.20. So $1.10 would be right in here. And they're asking for how many months was it greater than $1.10? So I count 1, 2, 3, 4, 5, 6, 7, 8. 8 months it was greater. Here it's actually at $1.10. So that would be 8. And then between which 2 months did we have the greatest increase in price? So an increase would be a jump. You're going from left to right. We're looking for the biggest jump. Looks like here, May to July, this went from, I'm looking here, that height. That looks like 90 would be about here. This looks like this went from 90 up to about $1.15. That'd be about a 20-cent hike. And then here, this one is going from about 125 to 140. That's only a 15-cent hike. So it looks like May to July. I'm sorry, May to June. Excuse me. What is the amount of the greatest decrease? Okay, so that would be a drop, and it's for consecutive months. So we're looking for the biggest drop. So here we were at $1.30, right? And it went down here. That looks like that's about, that's not $1.10, that's about $1.15. So that's a 15-cent drop. So try and look and see if we've got a bigger drop than that someplace else. This looks like this is another 15-cent drop. And all these drops, you know, this is a, looks like that's a 15-cent drop. Looks like that's the biggest. It occurs 3 times, but the amount of the drop is the same. It's about 0.15, 15 cents. And then what was the average price from January to May inclusive? Okay, so we want to average the prices in January, February, March, April, May. So in January we had $1.20. So we're going to add these up and then divide by 5 because they had 5 months. $1.30. So 1.3. Here in May, that's about 115. So that's a little more than halfway up. And then let's see here. April, we're at $1. And then May, we're at about 95 cents. Okay, so that's 5 months. We add those guys up and divide by 5. And so this total up on top here is 5.6. And if we divide that by 5, we get about $1. We get 1.12. So about $1.12 a gallon. Okay, so just some practice reading bar graphs, and line graph could be another possibility. I could give you a line graph. Number 9, we want to criticize this graph and see if there's any misuses in the display. So you're looking for things that are distorting the graph and could possibly be deceptive. So for example, I noticed this vertical scale, it starts at 5. It doesn't start at 0, so it makes it look, I mean, we don't even know what this graph tells us. There's no title, so you know that's one thing. If I want to criticize this graph and say, well, it's not done well, well, there's no title. We don't even know what this graph is telling us. Down here, these look like years, but we should have an axis label here. And up here, we should have an axis label. So there's no labels on the axis. No labels on the axes, either one of them. It's supposed to be on. And then also, this vertical scale doesn't start at 0. That's called a baseline change. You don't need to know that term. You just need to recognize that the vertical scale doesn't start at 0. So that can be deceptive sometimes because it makes the vertical heights look like they're in the wrong proportion. So, I mean, for example, it makes the point on the line graph in 1990 look like it's 3 times as high as it is in 91, but that's not the case. It's 6.5. Here it's 5.5. That's certainly not 3 times as much. So now it could be that they, took out part of that scale, for a reason, but they haven't shown us. They just started at 5. And then you'll want to check the scaling and see if there's an uneven scale. That's another way that things can get distorted. So these are all going up in increments of 0.5, and that's consistent all along that axis, so that's okay. And then here the years are going up 90, 1, 2, 3, 4, 5. It's going up 1 year at a time. They didn't skip a year and alter the scale here. So, but some things to look for are, also look for cases where you would have an altered scale. Either vertical or horizontal. Because those can distort the graph and be deceptive, make it look like things are the way they aren't. Alright, next we are given some information, a summary, table summary, and these are rates of return for different investments over a 5-year period. So here's the years up here, and then the investments in stocks, bonds, and then money market funds. So they want to know what's the appropriate kind of graph for displaying the data and explain. Well, these are percentages, but notice that in any one row or one column, they don't add up to 100%. So although they're percentages, they're not expressing parts of a whole. So if they were parts of a whole, then that would be a pie graph or a circle graph. But since they're just percentages that don't have to do with parts of a whole, they're just rates of return, then probably a line graph or a bar graph. Okay, so a line or a bar. And those would show trends over time, because our independent variable here is time. And they also, if we do a multi-line or multi-bar, will compare groups. And just as an aside here, percents that are part of a whole that would tell us a pie graph. Okay, so that's not what's going on in this question, but I could ask you something about a pie graph. So again, just try and give you an idea how I could change the questions. So now we want to make a graph of the data, using the type of graph we picked. So either a line graph or a bar graph. So I'll start with a line graph here. So our dependent variable, that's our vertical axis, that's going to be our percentage rate of return. And notice we did have a negative rate of return. So negative 8% for stocks. They went down one of those years. So that's the lowest value. And then the highest value is this 21%. So I'm going to put a horizontal axis on here, which is going to be the year. And then the vertical axis is going to be your percent return. And so that's going to go up to just above 20%. Move my label over here. And then we'll need down here a -10. So -10%, 0, 10, and 20%. So at year 1, 2, 3, 4, and 5, we want to graph these values. So stocks were 9% in year 1, so that would be about right here. And then 15% in year 2, so they're going to go up halfway between 10 and 20. 15 would be about right there. And then 21% in year 3, so we're up a little bit above 20 in year 3, about right there. 20% in year 4, so just slightly lower. And then -8% in year 5, so that's going to go down negative, about right here. And let's go ahead and connect those up with a line. So there's our line for stocks. So stocks will be black here. And then bonds, why don't we do bonds in blue? So bonds were 7% in that first year. So 5% would be about right here. 7% a little bit higher, about right there. And then 8% in year 2, just a touch higher. 5% in year 3, halfway between 0 and 10, about right there. 7% in year 4, so now they went back up a little bit. And then 6% in year 5, went back down slightly. And then we'll connect those up. And then over here are keys, so bonds were in blue. And then why don't we do money market in red? So that was 6%. Which is just a little bit lower than the bonds, so about right here. And then 8%, so it agreed with bonds in the second year, so that dot's going to be actually on top of that blue one. And then 7% in the third year, so it goes above the 5%, so about right here. And then 4%, so below that 7, down here. And then 5% in the last year, just a little bit below that 6, about right there. And then we connect those up. And we do our key here for money market. Use MM, and that's in red. And we could do the same thing with a multi-bar graph. So we could have 3 different types of bars, one for stocks, one for bonds, and one for money market. So again, I'm going to do the percent rate of return on the vertical. On the horizontal, I'm going to do the year. You want to make sure you label your axes, and I'm going to do the same labeling here. So there's 10, 20, 15, and 5 in between, -5, -10, and a 0 right here. And then we need our years, 1, 2, 3, 4, and 5. And now we're using bars instead of lines. So first let's do, why don't I do, we're going to have 3 bars for each year. We're going to have a bar that's return on stocks, one for bonds, and one for money market. And I'll do those in order left to right. So let me do the bonds first, because those are going to be centered right over the numbers. So 7% be about right there. And then 8%, just a little bit higher. It's not too bad. 5% in that third year. About right there. 7%. Going up a little bit higher in that fourth year. And then 6% in that fifth year. Okay, and then these are going to be our bonds. Our bonds were blue, so why don't I color those in blue? Okay, and then over here, and put a key, and our bonds are going to be blue. Okay, and then on the left-hand side, let's do the stocks, and let's do those in black. So we had a 9% return that first year. And start these bars right beside each other. Go up to 9% there. About the same width, but higher. And then we had 15% in the second year. So I'll start on the left-hand side of that bar, go up to height 15, right there. And then we had 21% in that third year. So starting here, we're going up to height 21. 20% in the fourth year here. So going up to height 20, about right there. And then negative 8% in that fifth year. So this bar is going to be negative. It goes below the axis like that, about right there, negative 8. Okay, and let's see here. Stocks will be black, so color those guys in. And then we'll do our money market, and those will be red. Okay, so let's see. Money markets were 6% that first year, just a little lower than bonds. So on this side, have a bar come up just slightly lower than that blue bar. And then 8%, so these were even. And then 7%, a little bit higher than that 5. And then 4%, be lower than this 7. About right there. And then the last one, 5%. And let's go ahead and color these guys red. Not what I wanted there. There we go. Alright, and we'll do our key. So our red here. And then we need some black for our stocks. Okay, so stocks in black, bonds, and then money market down here in red. So either one of those would be fine. And if I only had 2 groups to compare, I'd have 2 lines, and here I'd have 5 sets of 2 bars instead of 5 sets of 3, for example. Alright, in number 11, we're finding mean, median, and mode of the data that we have here, quiz scores. And so let's see, well, why don't we go ahead and put these in order, because to find the median we'll need to put them in order. So let's see, it looks like 12 is the lowest there. And then let's see here, we got a 12, looks like 2 15s. Okay, so 12, 15, 15, 18, and then 22. So 18, 22, and then 25, 26. Okay, so those are in order, 7 values, so we're going to have 1 middle, and we'll have 3 above and 3 below, like this. So 18 is going to be our median. So median is going to equal 18. Right there. And then let's see, our mean x bar, we're going to add them up and divide by 7. So it's just going to be 12 plus 15 plus 15 plus 18 plus 22 plus 25 plus 26, and divide everything by 7. And if you do the calculator work here, you will get a total on the top of 133 divided by 7 will give you 19. So you got a mode of 19, I'm sorry, a mean of 19, and then your mode is the most frequent score. And notice that we've got 2 15s and 1 of everything else. So your mode's going to be 15. So we are doing mean, median, mode in that order. So our mean was 19, our median was 18, and our mode was 15. So 19, 18, 15, that's C. Find the standard deviation of these quiz scores. So here we want to find standard deviation, we use the table. So we're going to list the individual x values. So the value, the mean, the difference, xi minus x bar, and then the square. So xi minus x bar quantity squared. So, and remember, standard deviation is measuring the spread of the data around the mean. So remember to use the mean in here and not the median. So let's go ahead and list our values in order here. So we've got 12, 15, 15, 18, 22, 25, and 26. I have a total row down on the bottom. Or sum row. X bar is the same for all of these, so our average was 19, so use 19 all the way down. And then we're going to subtract 19 from each of the data values. So that's the deviation. So 12 minus 19, negative 7, 15 minus 19, negative 4, 15 minus 19, another negative 4, 18 minus 19, negative 1, 22 minus 19, 3, 25 minus 19, 6, and 26 minus 19, 7. And if you add these up, they add up to 0, and that's your double check that the deviation column should always add to 0. Now we square all of these. So negative 7 squared is 49, negative 4 squared is 16, negative 4 squared again, 16. Negative 1 squared is 1. 3 squared, 9. 6 squared, 36. 7 squared, 49. Okay, sum all these up. If you do the calculator work there, you get 176. And then remember that our variance is the sum of the xi minus x bar squared column over n minus 1. So this top, that's this sum here, 176. And then remember here, the n, we've got 7 numbers here, n equals 7. So this is divided by 7 minus 1, divided by 6. And that gives 29.3 approximately. And then last step for standard deviation is to take the square root, because we've got to undo this squaring process. And if you do the calculator work there, you get 5.4 to the nearest decimal place, which is D. Okay, and this is measuring the spread in the data. Okay, measures the spread of the data, or the variation in the data, from the mean. So if we found standard deviation for another set of data and that value was higher than 5.4, they would be more spread out. Okay, number 13, we are finding a z-score. They give us a national average. Composite ACT is 21.1 with a standard deviation of 2.7. Olivet's average is 23.9. What's the z-score? Okay, so z-score here, remember, is x minus x bar over s. So it's the value minus the mean over the standard deviation. Well, the national average, so that's the average of all universities, is 21.1. So that is our x bar. And the standard deviation of 2.7, so that is our s. And then Olivet's average is 23.9. That's an individual college, so that's our individual data value x. So x is 23.9 minus the x bar is the 21.1, and then s is our 2.7. So if you plug these into the calculator, round to 2 decimal places, you get 1.04. Okay, and what does that z-score mean? So number 14, interpret the z-score above, explain what it means. What it means is that the GPA that's associated with the z-score of 1.04 is 1.04 standard deviations above the mean. Okay, so Olivet's ACT score and Olivet's score was 23.9. 23.9 is 1.04 standard deviations above the mean. Above because it's positive. If it was a negative z-score, it would be below the mean. And if it was exactly at 1, it would be 1 standard deviation above. If it was negative 1, it would be 1 standard deviation below. So remember, this is telling on the mound-shaped curve, on the bell curve, how far above and below you are from the mean, which is also going to tell your percentile. And that's the next problem. So if we assume a normal distribution, so that's the bell-shaped curve, of the average scores in problem 11. Oh, that's the wrong problem number. Problem 13. So the continuation of this problem. then approximately what percent of the national ACT average scores are below Olivet's? And the hint is to use the table. Okay, so sketch our bell-shaped curve here. And basically what we're doing is we're finding the percentile. So down here in the middle is a z-score of 0. That corresponds to the 21.1, the national average. Okay, and then Olivet's score is z-score is 1.04. So remember that the z-scores range from 1, 2, 3 above to 1, 2, 3 below, and that contains virtually 100% of the data are within 3 standard deviations below to 3 above. So a z-score of 1.04 is just past 1 standard deviation above. So this would be a z-score of 1.04, about right in there. And then what we want to know is what percent of the scores are below Olivet's. So how much is below? How much is to the left? Well, we'll have this piece right here is to the left. And that's the left half of the bell-shaped curve. And that is 50% of the data, or 0.5. And then we'll have this area in here, which is below. Okay, let me put some color in there. Okay, so we want to find this shaded area, the total shaded area. This much we know over here is 0.5. And then this area in here, whoops, this area in here, that we get from the table. That's the percent of the data that's between 0 and 1.04. So if we go to the z-score table, okay, area underneath the normal curve, which tells us the percent of the data, and we want to find 1.04. So we want to go down to the 1.0 row and across to the 0.04 column, okay, because this number, 1.0, and this one, the 0.04, have to add up to make the 1.04. So if I follow across the 1.0 row until I'm in the 0.04 column, I'm right here at 0.3508, and that gives me the shaded area here from 0 out to the z-score, which is 1.04. So this is 0.3508. And so these two pieces together is going to be the total that's below the 1.04. And so our total is going to be 0.5 plus 0.3508, which is 0.8508, which is 85.08%. And so all these are rounded to the nearest percent, and we want this guy right here. That should be a 5. And I believe it is a 5 on your copy of the exam, on your printed copy. And then last of all here, we're just labeling mean, median, and mode on the distribution. So this distribution is skewed to the right, so it's getting pulled to the right. And what pulls it to the right is the extreme values. And the one that gets pulled is the mean. Okay, so this C, that's got to be the mean. So let's label A equals, B equals, and C equals. So C's got to be the mean because it's the one that gets pulled. A is underneath the highest point. And remember that frequency goes up in this direction. So the highest point means the highest frequency. That's going to be the mode. So A is the mode. And then the median cuts the area in half, but then the median is the middle, and it's going to be in between the mode and the mean. So B is in between, it's the median. but it splits the area in half. 50% above B and 50% below B. Now the way I have it drawn, it looks like there's a little bit more. It looks like this piece here is a little bit bigger than this one. Looks like it's maybe more a 60-40 split. So I maybe should have this moved over a little bit. But this area looks smaller, but it's got a longer tail. Okay, but these two are the same. The area above B and the area below B. Okay, so let's see. Oh, there's one thing I wanted to mention when we did mean, median, mode in here. Also, look back. Also, look over the homework where we did grouped mean, median, and mode. So, homework for grouped data. So you had some homework exercises where you were given a table, so you had group data, and you needed to find mean, median, and mode. That's one variation that I could do of this question. Okay, I think that should be a wrap.